Good morning, student. Today we will continue the chapter electricity. Heating effect of electric current. What is heating effect? First, what is heating effect? Okay. Uh, when the electric current is passed through a resistance wire, the wire gets heated. This is called the heating effect of electric current. Okay. Uh, The speed of the electrons does not increase continuously because they frequently collide on their way with the positive ion of the wires and are slowed down. Thus, they transfer the electric energy to the lattice ions of the wire. The ions vibrate about their mean position more and more violently, and the temperature of the wire rises. Thus, electric energy is converted into heat energy, and this effect is used in instruments like electric bulb, heater, um, uh, arc lamp, iron, etc. Calculating of the con consumed electric effect of a conductor. Calculation of consumed electrical energy in a conductor. Okay. If W joule work is done by flowing Q. Q means small q, means or capital Q means coulomb charge in a conductor in which potential difference at the two ends is capital V volt, then according to the definition of the potential difference, and V is equal to W upon Q. V means volt, W means the unit of the W is joule and the unit of the Q is coulomb. Okay. And if a charge Q flows through a conductor in time t, then according to the definition of the current flowing in a conductor I is equal to Q upon T, where I is equal to current and Q is equal to coulomb charge and T is equal to time. So, Q is equal to IT. So, the Q is equal to IT. Okay. Uh, and the combination of the two reaction, and that is W is equal to VIT. And if the resistance of the conductor is R, then the Ohm's law V is equal to IR, or I is equal to V upon R, or the value of V in equation third. So, the W is equal to I square R T. Okay. So, W is equal to VIT or I square RT or V square T upon R. Calculation of heat produced in a conductor or heat evolved in a conductor. If a conductor in a conductor, if electrical energy is not transferred into the mechanical or the chemical energy or the both, then it is transformed into heat energy. Or in other words, heat evolved in a conductor is a form of electrical energy. So, heat evolved in a conductor is measured in joule. Usually, heat energy is measured in calorie. If heat is measured in the calories, then it can be converted into joule by the following relations. Okay, 1 calorie is equal to 4.2 joule approximately, okay, or 1 joule is equal to 1 upon 4.2 calorie. Okay, so there are three formula. First is equal to H equal to VIT joule, or H is equal to I square RT, or H is equal to V square T upon R. As you shown in the following equation, and the formula it is equal that heat is proportional to current or heat is proportional to resistance. Okay, if we double the resistance, then the heat produced will also double, okay, because they are proportional to each other, or heat is proportional to time. So, the three laws mentioned above known as the Joule's law of heating effect. These laws was given by the James Prescott Joule. Application of the heating effect of electric current. Okay. There are a number of such devices on which electric appliances applications on the heating effect is used, and the first is electric bulb. Light can be produced by the electric current. Um, when electricity is passed through the resistance wires of the bulb, heat is evolved. Its temperature rises and it begins to glow. Electric bulb consists of a glass globe, upper portion of which is seated with a bad conductor. Two copper wires entered into the bulb through this non-conducting sealed cap. The end of these wires inside the bulb are joined to the made of a filament. Current in the both bulb passes through this filament. Uh, the glass bulb is made up of airtight. Air is removed, and um, high power bulb of the high power are filled with a mixture of nitrogen and argon. Air is taken out from the bulb. Okay. Um, when the electric current flows through an air exhausting bulb, the temperature of the filament rises about beyond the 2100 Celsius. Okay. And the second is electric heater. An electric heater is an important application of heating effect of current. When current flows through a wire, heat is generated. An electric heater works on the same principle like bulb. Um, A long coil of nichrome wire is set up in a plate of china clay. This clay is used because its bad conducting nature. Both the ends of the wires are connected to the two adjacent switches or screws. From these screws, the heater is connected to the main line of the electric current. Due to the high resistance of the coil, the room heater or heater is immerses the rod and the electric generate in it. And the third is electric fuse. And an electric circuit which is fed with the electric power from the main, sometimes a short circuit occurs. It means that the two wires negative and positive come in contact due to the same fault in the application or due to their insulation being worn out. Okay. If it happens, then the resistance of the circuit decreases with a very low value and hence the current increase, and this hits the line wire and the produce the electric current in the place of the short circuit. So, a fuse is a short piece of wire made up of a material of high resistance and a low melting point. Okay. However, uh, when the current is increased largely, fuse wires melt and disconnect the circuit. The thickness of the wire is different in the different fuse. Generally, an alloy of lead and tin is used as the material of the fuse wire. And the next is electric power. Electric power. Uh, the rate of the doing work by a body is known as its power. In other words, we can say that the power of a body is the amount of work which is done by the body in the unit time. Also, any other electrical circuit, rate of the electrical energy is spent is called the electric power. It is generally denoted by P. So, the power is amount of work done upon total time. P is equal to W upon T. P is equal to W upon T. Uh, and the unit of the power is unit of the power is watt. Okay. If V is measured in volt, T in I is ampere, and the unit of P will be joule per second or watt. Thus, if a potential difference of 1 V causes a current of 1 ampere to flow through a conductor, the electrical power consumed will be 1 watt. Okay, calculating of the power, electric power. Okay, electric power in term of the potential difference V and I. So, the P is equal to W upon T is equal to VIT upon T. So, the P is equal to VI watt. Okay, and in the term of potential difference and resistance, and the formula is P is equal to V square upon R watt, or in the term of electric power, in the term of current and resistance, and the formula is P is equal to I square R. So the electric power is P is equal to VI upon V square upon R and is equal to I square R watt. So what is the small unit of electric power? In the other large unit are the kilowatt and the megawatt. These larger units are used in the large application. So the 1 kilo is equal to 1000 watt, or 1 megawatt is equal to 10 to power 6 watt. And in the machines, unit of the powers is horsepowers. So the 1 horsepower is equal to 746 watt. And the relation between the kilowatt hour and joule. 1 kilowatt is equal to 3.6 into 10 to power 6 joule, or 1 megawatt is equal to 10 to power 6 watt, or 1 megawatt hour is equal to 10 to power 6 watt hour. Measurement of the electric energy consumed in homes. If an circuit at a potential difference, that is V volt, a current I flows for T hours, then the electric energy consumed in the circuit is W is equal to PT. Therefore, kilowatt hour, or the number of unit, is equal to VIT upon 1000. VIT upon 1000.